Got 6 examples. Let's knock them out. So what I wanted to add on today, you certainly did not need another whole period to finish assignment 5. There's no way that's going to be the case. So I wanted to add this in today, make efficient use of our time. So if you're on your Chromebooks, make sure you wrap up whatever it is you're doing. I want those closed within about 30 seconds. I assume you're getting yourself into an RTI, but you certainly wouldn't be working on your assignment while we're supposed to be taking notes. So no Chromebooks, please. Just notes. I'll be fast, I promise. So the message for today is that equations are now going to start requiring some work before you actually do what we did yesterday. So the point of yesterday's lesson was to show you what you do when the equation comes down to the end. And the end almost always looks the same. On the left side, there'll be a letter and a number, and on the right side, there'll be a letter and a number. And you should cruise control through those final 3 steps. So the purpose of today's notes are to show us what it looks like before we get to that point. So the name of the notes, I decided to call them simplified then solve, and that's really going to be an issue. So today, I hope this goes well. I hope I can like penetrate this message into your brain and get it stuck there. The mistakes people make on problems like this is they say weird things like, let's add 36 to both sides, or, weird stuff like that. What we need to think of is we need to think of the left side of the math problem as its own island, its own math problem. And we need to think of the right side as its own problem. As far as you're concerned at this point in time, there's not an equation on the board. There are 2 math expressions that need to be worked on. And then once we've worked on them and gotten them to their best, most pristine and clean state, then we'll do the thing where we, move the variables to one side and all that. So if you think of the yellow one, forgetting everything else in the problem, just yellow, focusing on yellow, what would you say to do? Combine like terms, right? It's every situation is different. I mean, sometimes it's distribute, sometimes it's combine like terms, sometimes it's already done. But in this case, you can clearly see that a -3, wrong color. You can clearly see that a -3m and a -4m can be added together to make
-8.
-7m.
No,
You're fine. No, you're fine.
you added the m's with it.
Got rid of that. -3 somethings minus 4 somethings just gives you -7 somethings. That's all. And now the left side, we would all agree is done. There's nothing else I can do on the left. Those are not like terms. There's no parentheses, nothing like that. So let's switch our attention to the red side. What could we do, or should we, or do we have to do on that side?
The
distribution is essential here. So we're going to take the -6 and we're going to multiply it here. What are we going to get? It's not 18. If you say 18, you're off by 36. It's -18. Yeah. Again, I'm not going to play that. That's what I meant game. Like negatives and positives will be our downfall if we're not respectful of them. So that's -18m. And then what is the second distribution all the way across to here?
-30.
It is positive. It switches to positive because we have a negative being distributed onto an already minus or negative, whatever you want to call it. So those are going to join forces and become a +30. It's at this point that we rejoin yesterday's lesson. Like this is now the new push for today is how do I get 2 problems that look like yesterday? And from this point on, we kick into auto mode where we go step 1, variables to one side. Step 2, numbers to the opposite side. Step 3, divide if necessary. Got it?
Add 18m.
Definitely is the only perfect answer I want, Seth. You nailed it, is to add 18m to both sides. Because like a hawk, you should be focusing on the ones that have the variables with them. Heck with the 36 and the 30. We're not interested. We're going to go target the one that's smaller. -18 is way smaller than -7, so we're going to eliminate it by adding 18m to both sides. Like this. And then we're going to be left with 11m minus 36 equals 30. So you see now, again, we've rejoined yesterday's party. Like we're trying to get everything today to look like they did yesterday. And the practice gets us to a point where we don't even really have to think as we go through these steps. What has to be the next step?
Or add 36.
Adding the 36 across to be with his homie is the right answer. Like there's no way around the fact that, the m's have taken over this left side. The numbers now need to vacate and head over to the right side, giving us 66. Final step. Mhm. And if we divide both sides by 11, we
Then
finish,
6.
get m equals 6, right? So we're going to practice this a few more times just to make sure the point gets driven home. I do not want you adding things to both sides or subtracting things on both sides until each side is as clean and perfect as it can be. That's the hardest habit for me to break kids out of in this ninth grade year. It's the one I fight a lot. So tell me about this left side. It's good to go. So we're just going to kind of put that one on hold and say left side,
Would we
sit, wait.
combine like terms on the outside?
We would. On the right-hand side, it's always going to be a matter of just what math can I do? The word simplify is so all-encompassing. It just means do math until you run out of math. It can mean 50 different things, right? But yeah, like Seth said, put these red ones together. What is 2x's minus 4x's?
2x.
Yeah.
-2.
And, I always hate to say this because I'm not trying to make anyone feel bad, but that's the kind of math that if you stumble with, we'll have a harder time all year with the things we're trying to accomplish. You should not even, it should take you less than an 18th of a second to do 2 minus 4. FYI, it's where you should all be. I did this problem on purpose because I wanted to have a quick conversation with you about an exception to something I told you yesterday. Yesterday, I tried to impose upon you my opinion that you should always pick on the smaller variable term. And you're no dum-dums. You understand that when you look at the x's, because that's what my bossy teacher said to do, is get the x's onto the same side. Who's smaller, the 3x or the negative 2x?
-2.
So if you follow what I did yesterday, which I'm going to do it. Don't do this with me. I know I do notes like C notes, write notes. In this case, don't write this down because I'm going to do something and talk to you about why it's a bad move. If I follow my teacher's opinion or directive or guidance, I add 2x because that's smaller and I want to get rid of it, right? What problem do I put myself in?
5 plus 50.
There's nothing on the right side. And if you're still listening, which I hope you are at this point, please hear me say this. You do not until we do quadratics in like November or whenever we do that, you do not want to void an entire side out. And that's the position we put ourselves in. And sometimes we have to go against our judgment and say, you know what, even though I would like to add 2x, I know what's going to happen if I do that is the right side's going to go empty. Do you see that, right? And again, I'll finish this, but don't stay with me. Don't do this. I would wind up with 5x plus 15 equals the great nothing. And now I'm like, well, this isn't the end of the world. Now I could just move the 15 back across. But I ask myself, why would I put myself in that position? Why would I make more work for myself? So going back in time, I would sacrifice like what I want to do. And I would say, well, I'm going to suck it up and subtract 3x from both sides. Sometimes you're going to move the one that you don't want to move just to keep something of substance on both sides of the scale. Okay. So the choice is usually yours, but sometimes you kind of get bullied into it by the problem itself. So these 3x's cancel and we're left with 15 equals how many x's?
-5x.
Mm-hmm. Right. So again, keep balance, keep stuff on both sides. Don't forget that.
Now you can divide 5x by 15.
We divide both sides of the equation by -5. That's how we say that. And then we cancel out the -5s, bringing down our answer, which is -3. Okay. Any questions on that so far? Okay, let's do another one. I will always try to make my sixes not look like B's, but do understand that that's just kind of, it's an unfortunate reality. I'll try to make my B's like that, and I do understand that they do look a lot like that. So Again, it has to be an island sort of thing. You cannot look at this as a math equation. You cannot do that. It will be your downfall. You have to look at the left side as a math problem and the right side as a math problem. And we do each one first. What goes on the red side?
The right or the red?
Red.
Okay. You would distribute
You would distribute. What is
the
that?
2 and 6 to the 6.
So what do we get?
Negative.
We get negative 12. Nope.
36.
Plus 36W. And then on the right-hand side, rinse and repeat. See parentheses, kill parentheses. Like it's got to just be a robotic
Distribute 7 and 4 and
response.
8.
What is 7 times 4? 28.
Mhm.
7 times 8W is
Mm.
no. Moments like this are where I realize that if I were doing my job correctly, I would ban calculators from this class completely. This is a little bit offensive that a room full of ninth graders just got vexed by 7 times 8. Thank you, whoever said that. It is 56. So if calculators do get banned, remember that moment in time where not a one of us could come up with 7 times 8. Just consider that it's done out of love. Okay. So at this point now, we look at the left side and we ask ourselves, what can we do? What is the answer? Nothing. Good. Look at the right side. What can we do? Nothing. Good. So now this is where we're forced into thinking of this as a yesterday problem. If the left side is done and the right side is done, we can now head into solve the equation mode, right? Okay. So let's consider which W should we move?
The 36.
36 is smaller, and we do have the choice this time. Like there's no one bullying us into backing us into a corner. So we're all going to subtract 36 of those W's on both sides. What are we going to be left with? Yeah, I mean, like the whole equation. I got to work on how I ask that question. Negative 12 equals 28
plus 12.
plus 20W. 56 minus 36 is 20. At this point, there are no more options. Okay, we've positioned ourselves to where there's only one right thing to do. Who has to move? 28 is the only one because the W's has said this east side is ours. Everyone else clear out. And for that reason, the 28 says, understand, point taken, I will show myself out. He's about to get beat up by all the W terms. So he's going to leave like this. And what do we have on this left to right? Read me the whole problem. What does it say?
Negative 40
Perfect.
equals 40.
Mhm.
And then you divide both sides by 20.
It is correct. Nailed it. And I love the way you said that. Divide both sides by 20, those sweet words. And what does W equal? Okay. I've got 2 more that I want to do with you. I had 3, but I think we don't need all 3. I think one of them is a repeat that we can do without. So we're going to do 2 more math problems and then it'll be work time. So this one is going to be 3y plus 9y is equal to negative 3 times negative 5 minus 3y minus 3 times negative 2y plus 7.
Jesus.
So we're getting closer to the point where these things can look a little bit scary, but with the proper mindset, skill set, the only thing we're going to not see for a while is the ones that have the gnarly fractions in them. But at this point, having sat through this, you should be able to solve just about anything. Like you've got the skills. We're not going to be overwhelmed by this. We're not going to look at it. We're going to
had to restart my problem and go like way over to the left because I didn't know it was that one.
It's a upper. So we would all agree that on the red side, we can put those together to get 12y.
12y equals, and then you distribute negative 3 to the negative 5 and the negative 3.
Right. So on the right-hand side, we have to be mindful of the fact that there are 2 completely separate distributions. The yellow and the green are completely unrelated to each other. Sometimes you'll have to distribute more than once. It is what it is.
So would it be 12y equal
So here we go.
-8? Or did I go the wrong way?
We're multiplying.
Um,
Distribution is multiplication.
15. No, it'd be 15.
15
And then it'd be 6,
plus 3
Plus
times 3 is 9. Why?
9, and then plus 6. Or minus, I don't know.
You're fine. The next distribution is the purple number. Okay, so we survived the first number, remembering to change our signs and all that as we went. And now we're on to Mr. Purple, and his job is to multiply again. Be cognizant of the signs. When you multiply by a negative, signs change. So we're left with positive 6y. And then what's negative 3 times 7?
-21.
Perfect. So my job again is to try to coach out of you saying stupid things like let's add 21 to both sides, or ooh, let's move the 12y. That's one of the hardest parts of my job this entire year, is to convince an entire new group of kids that we are not ready to solve this equation. We can all agree that the red side is done.
Mhm.
We must, however, all agree that the yellow side needs work. So we're not going to use the words both sides. We're going to combine like terms. And it's local combining. We're not doing like both sides stuff. We are just looking at the yellow thing and saying, what can I do for you?
Combine the 9y and 6.
So let's take this 9y that's positive and this 6y that's positive and add them up. What do we get?
15y.
We do. And then let's also take this 15 that doesn't have a variable and this minus 21. What's 15 minus 21?
Negative. No.
Definitely negative. So we're going to put minus 6.
And then you drop to 12y equal.
And this is what the equation looks like once it's in its simplified and ready to go state.
And we'd want to get rid of that 15y.
Very good. So remember, this is kind of like the problem I gave you earlier, that we don't have a choice at this point. I mean, you do, but you'd be a fool to subtract the 12y, the smaller one, until you're really expert and you can start doing multiple things at once. We're at the point in our learning right now where it makes more sense to just take the 15y and move it. And that way there, we assure ourselves that we keep some substance on the left and we also keep some substance on the right.
18 equals.
So what is 12 Ys? If you had 12 Ys in your pocket, or you had $12 in your bank account, and you spend 15 on your debit card,
It'd be -3.
it would be -3. And then you bring down the number. The artist formerly known as -6 is now known as
And
-6,
then you
right?
divide both sides by -3.
Correct. And when you do that, you wind up with y equals +2. Okay. Feeling it?
A lot simpler than what the problem makes it look like.
Simple, right. And that's what you're going to find with most everything that we do, is that equations like this, they're not as hard as you probably think. You just have faith, distribute, combine like terms, and then do your thing. Okay. One more. Tell me about this red side.
And you did
Distribute.
before
Boom.
that one
And boom.
before the 3.
So what are the answers to those two red arrows?
4 and
4x.
4x minus 12.
Perfect. Just
Oh,
12.
just 12,
No
sorry.
x. Mhm.
3x.
And then we do just take this -2x and transfer it down like this, and we'll deal with him in the next step. Tell me about the yellow side. What are we going to do over here?
You're gonna distribute the 5 to the 1 and the 5 to the -1. and you should get 5 and -5, or 5 minus 5.
Careful, please study your first yellow arrow again. 5 times x is 5x.
5x minus 5 plus 5.
Right? It's always going to be the order in which you do stuff, right? Parentheses need to go first. Joseph, what's next, buddy?
Like 5 is 5 ridiculous.
It will. Then we're going to do that now in the next step. The next step is to start thinking about like terms. Step 1, we have to survive distribution. We can't be making mistakes there. We gotta survive and move on. And so on this red side, I see a 4x and a minus 2x that can be put together. What do they make?
2x.
2x. And then we copy down the minus 12. And then on the yellow side, like Joseph pointed out, we do in fact see that these are like terms like this.
It would be positive 5, right?
So it would just be
0.
5x is what we did. Because these two are 0, and you don't want to put zeros in equations. It's creepy.
And
It's a
then you want to
waste
get
of
rid of that
space.
12. You want to add 12 to both sides. Yeah. No.
Let's think about what we're trying to accomplish. Remember, we're trying to accomplish separation at this point, and the 12 has nowhere to go.
So you'd minus 2x from both sides.
Right. And so at this point, we're being bullied. This is a bully problem where we don't want, we don't have the freedom maybe that we sometimes have. In this case, though, it does coincide. Like 2x does happen to be smaller, but it's not what our thinking is. Our thinking is we're subtracting 2x, not because it's smaller, but because I know that I don't want to void one side. I don't want one side to go just empty. So I'm going to bring down the minus as a negative 3x.
And then you divide both sides by the positive.
Correct. And then we're left with this. If somehow you made it through today's lesson without getting this memo, let me send it one more time. You must simplify completely before you solve. Using the words both sides should not happen until you get the equation down to its cleanest state. Will you two gentlemen in the back, after I hit pause, come up here and visit with me in just a moment? Thanks. You know who you are. Anyone have any questions about it? The remainder of your time today is, bless you, by the way, is to work on assignment 5 and assignment 6. If you're on 5 on your Chromebooks, just remember I'll be closing tabs if you're not in Delta Math. And if you're on 6, 6 is not whiteboard because this is, you're not going to have any evidence of the work. So recommend that you just use pencil and paper. It's always my advice.
So do we have permission to use a whiteboard for Delta Math? Thank you.